Hello, honors geometry students. Let's take a look at some of the problems from the topic 11 review, starting with problem number 12. A full waterbed mattress is 6 feet by 3 feet by 1 foot. The mattress is to be filled with water, and by the way, water weighs about 62.4 pounds per cubic foot. How much does the bed weigh, or the mattress? All right, so we have volume here. We need to calculate that in terms of cubic feet first. Um, don't know about you guys, but most of the time, a mattress to me looks like a right rectangular prism. And again, for something that simple, it's a box. Length times width times height. So 6 times 3 times 1. It has a volume of 18 cubic feet. And if for every cubic feet the water weighs 62.4 pounds, directions say round that off to the nearest pound, so 1,123. Let's take a look at 13. Seems like we did one of these back in section number 2. We have 2 flood control ditches shown. Which one has the greater volume of water per foot? Um, Yeah, we just need to compare. Please note here, again, we have mixed units of measurement, so we need to be careful. Inches, 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 but feet, inches, inches, and feet. Well, it's nice that both of them there have the exact same width, so that'll be much easier to compare them. But again, the website asked for you to actually calculate the volume. So let's see, for the trapezoid, we're going to use volume of a prism. So we need area of the base. Well, in this case, the base is a trapezoid. Area of a trapezoid will take 1/2 times the height of the trapezoid. Again, that distance between the bases is 150, multiplied by the sum of the bases, which in this case is 300 and 200. So it'll give us area of the base. And then we have to multiply it by the height. Again, for volume here, area of the base times the height. The height is that perpendicular distance between the bases, which in this case is 5 feet. But hold on. If these are measured in inches, I can't just multiply it by 5. I've got to convert that. 1 foot is 12 inches. 5 times 12, that's 60 inches. So again, to the calculator here. Order of operations, 300 plus 200 is 500. Then inside the brackets, you can multiply that in any order you want. Half of 500 would be 250. So if I take the 250, multiply it by the 150 times the height of 60, that gives me a volume there of 2,250,000. Inches, inches, inches. This is in cubic inches. Now, for the volume of a cylinder, we've got the slightly more specific pi r squared h. Again, pi r squared, the base of a circle, the base of a cylinder is a circle. Area of a circle, pi r squared. But in this case, for our ditch, it's a half cylinder. So I just need a nice little fraction out front. Pi times, to me, it shows the radius is 150 square that times the same perpendicular distance between the semicircle bases is again 60. Again, no order of operations here. Everything is equal priority, so I can take half of the 60. That'd be 30. So I need... Oh, look, I did that already. No, I probably need to round that off to something reasonable. Pi times 150 squared times 30. Oh, let's say 2,121,000. Let's round it off there. So this is approximately 2,121,000 cubic inches. And then comparing those two, clearly the trapezoidal ditch holds a much greater volume of water. All right, let's move on to 14. Again, this one sounds awfully familiar. Inez's younger brother will be home in about half an hour. Her garden hose will fill up the pool at a rate of 24 gallons per minute. Does she have enough time? All right, so again, they're giving us the conversion factor here that in 1 cubic foot of volume, that'll hold 7.48 gallons, in this case, of water. Again, the pool itself, I would consider to be a cylinder. So again, we have our formula, pi r squared h. The h is going to be this 3-foot measurement there. But now we need to do some thinking here about the radius. Now they're telling us here 9 feet, but that's, to me, clearly that's the diameter is 9 feet, which means the radius to the outside, careful, outside edges there would be 4.5 feet. But it's not going to fill up this outside part of it, it's going to fill up the inside part of it. So let's say that's the diameter of the outside, the radius of the outside. We're looking for the radius of the inside portion of it here. So that's going to take off 10 inches from the 4.5 feet. So again, if they're wanting everything in terms of feet or cubic feet, we need to, first of all, take that 10 inches and convert that into feet. 5 over 6 reduces down. Our decimal then is 0.833333 repeating. So if we take the radius of the outside and subtract the width of the pool wall, I guess we could say, that's going to give us our inside radius is 3 2/3. But then, I don't know about these people. The inner radius of the pool is, they want it measured in feet, round to 1 decimal place as needed. If we follow their directions, I guess we could say that's about, I'm going to switch that, is approximately 3.7 feet. Okay, so then for volume, we're going to take pi times our, I'm going to change that, approximate volume, the 3.7 squared times the height of 3. And let's force it to do a decimal approximation there. So that works out to be about 129 cubic feet of water. And again, if in each of those cubic feet there are 7.48 gallons, we take this, multiply that by the 7.48, That should give us about 965. Okay, now they actually want it to the nearest tenth. Don't understand these people. 165.1. Again, that's, and if the hose can go at a rate of 24 gallons per minute, we'll take that, divide it by the 24, and find out that, well, Junior's just going to have to wait a little bit. It's going to take a little bit more than 40 minutes to fill up the pool. Yeah, okay. Okay, problem number 15, volume of the cylinder is given to us. Well, wasn't that nice of them to leave it in terms of pi? Again, we know volume of the cylinder, pi r squared h. So in this case, they tell us the volume is 1,225 pi. That has to be equal to pi times the radius of the base, they say is 7 squared times, solve it for the height. Okay, so one of the first things we should do, divide both sides by pi and reduce that down. Again, wasn't that nice of them to do it that way? So I can say 1,225 is equal to 7 squared times h. Well, 7 squared, hopefully we know that without a calculator, is 49. Divide both sides by 49. The height of the cylinder has to be 25. Sorry. Centimeters. Okay, couple of clues there. The volume was given in cubic centimeters, so that's going to be our measurement here. They also told you the radius of the base. They gave you that length, one dimensional. That distance is in centimeters. The height should also be one dimensional. That should also be centimeters. All right, jumping over to 21. This was kind of interesting. The cone is inscribed in a right square pyramid. What is the remaining volume if the cone is removed? Okay, so we're looking at here the volume of a pyramid compared to the volume of a cone. Okay. Now, hopefully, again, if they're telling us here the cone is inscribed in the pyramid, we can say that the volume of the cone is less than the volume of the pyramid. And to figure out if the cone is removed, what's the remaining volume, we're going to subtract those two. Okay, so for volume of a pyramid, we have our lovely formula where we need to take 1/3 times area of the base. Well, in this case, they tell us it's a square base for our pyramid. The markings here look like it's 22 on each side. So area of a square, we'll take 22 and square it, times the height of the pyramid they're showing us is 18. The volume of a cone, again, that's just volume of a cylinder with our standard 1/3 proportion in front of it here. Now, for this, we need 1/3 pi times our radius squared. So if the square base of the pyramid is 22 inches on each side, that means stretching all the way across here. It's inscribed in here. The diameter of our circular base is also 22. If the diameter is 22, the radius has to be 11, and they have equal heights. So now it's just a matter of crunching the numbers there. So 1/3 of 18, I hope that's 6. Otherwise, I need to go and get more sleep. So I could take then 22 squared times 6. So that'll get me the volume of the pyramid that's on the outside. But from that, then I need to subtract here for the volume of the cone. Again, 1/3 of 18 is 6. So I need pi times, well, I know I don't need a calculator for this one. 11 squared is 121 times 6. So I get pi times 121 times 6. And again, with your Inspire calculators, it's going to follow order of operations there. So let's force the decimal approximation on that. So if the direction said to the nearest tenth, let's round that off at 623.2. Now in this case, they didn't give you any kind of, didn't say centimeters, feet, parsecs, whatnot. We don't need units of measurement for our final answer. 22 was the next one somebody asked about. So let's take a look at this rather interesting figure here. To me, this appears to be a prism on the bottom with a pyramid on the top. So to find the volume of the whole thing, I'm going to take the volume of that bottom prism, and to that I'm going to add the volume of that pyramid that's on the top. And again, they tell us here off to the side that it's a square base. So again, volume, it's basically volume of a box. I have to take length times the width times the height. Okay, that won't be too tough. Now for our pyramid, again, don't forget the magic constant there of 1/3. The area of the base, again, it's going to be a square, so that's 21 squared. And they're showing you, wasn't that nice of them, the height of the pyramid is 12. So that's our prismatic base. Got these already. Well, gee, again, how about a little bit of mental math here? 1/3 of 12 is just 4. 21 squared times 4. So goody, no rounding needed here. 7938. And again, everything's measured in feet, so this is in cubic feet. Because again, volume is three-dimensional. Let's take a look at number 25. In terms of the radius, what is the volume of a cone whose height is equal to the radius? Well, again, let's start with our formula. Volume of a cone, 1/3 pi r squared h. Well, in this case, the height is equal to the radius, so this is 1/3 pi r squared times r, implied to be r to the first. 1/3 pi times the radius cubed. Now, I'm not sure exactly how forgiving the website here was with how you need to type that in. Again, we had 1/3 pi r cubed. And what they have here is taking all of these and putting this over 1 and this over 1, so we have pi r cubed over 3, and that's all. That's what they're showing there. Those are equivalent, don't worry about that. All right, have to do some thinking here with 26 before we start plugging things into any kind of a formula. What's the volume of the largest right circular cone that will fit entirely within the right square prism? I mean, did they really have to say circular cone? Anyway, so we could use this base here that's 8 by 8, the nice square, and put in a circle that goes all the way across this base. That's not nice looking. So we could stretch it across this way and then go to the top here. Okay, that might be worth looking at. That would certainly give us a fairly wide base. Another way that we could, to me this seems like the least plausible, we could put our circular base on, say, this face here, and then stretch the cone to the opposite side here. That's going to give us a very small base with a height of 8. Definitely taller than that first option. Or we could stretch one, say, across the front here. And then go back to some point in the back here. So again, we would have a height of 8. But again, it's going to limit our circular base. So I would say the first one is going to be our best option there. So we're looking at volume of a cone, pi r squared. Now again, if we're putting the circular base here, stretching across this part, and again, it doesn't really matter, in my opinion here, where we put this. That's going to be the width of the base is going to be equal to 8, which is the diameter of that circle. If the diameter of the circle is 8, then the radius has to be 4. And again, it's 1/3 pi r squared h. And then we're going to go from here up to some point in the top of it, which means the height of the cone is also going to be 4. So again, 4 squared is 16. 16 times 4 gives you 64. So this is 1/3 times 64 pi. And again, if we want to put that all as one fraction, 64 pi over 3. And again, they didn't give us any units of measurement, so we don't have to worry about coming up with that. And then the last one here, 29, asking you to do a little bit of mental math. If the radius of a sphere is, oh my goodness, what an interesting, square root of 2 divided by 3.14 yards, what's the surface area? Use 3.14 for pi, use pencil and paper, explain why you can use mental math. All right, so we know for surface area of a sphere, that's 4 pi r squared. So if they're telling us here that the radius is the square root of 2 over 3.14, well, they're saying use 3.14 for pi. I'm going to use pi for 3.14. If they're giving me a conversion factor, it should go both ways. So 4 pi times, well, the square root squared, those are inverse operations. So that'll give me 2 over pi. times 4 pi over 1, I can reduce those. 2 times 4, it's 8 square yards.